So just a quick word of intro of why I did this talk and why, like, what I'm trying to do with this. I see lots of people being scared of regular expressions often, and not using them because they think it's like they will be unreadable or not maintainable and so on. So I thought if maybe this misunderstanding is the cause for the fear. So I thought if we go through everything and just like make sure everyone gets a good understanding, you might be less afraid of using them. So we'll see how that goes, but I'll try and do that. So shortly about me, I'm working these days at teamup.com. Few people asked me that yesterday evening, so that's that. Otherwise, yeah, I'm still doing Composer and so on. So let's start with some history. It all started in the 50s, where Stephen Colclean was a mathematician, wrote a paper about natural languages, regular languages, sorry. And that was kind of the basis for regular expressions. So it included some of the syntax we see. But then, like, for 10 years, nothing happened, and then Ken Thompson came around and wrote this, like, early days editor called QED. And that was, like, using regular expressions to match, like, to do search and so on in the files. Then a few years later, he started working on Unix and built another editor, like Ed, that also had those features in. And one of the features was also like called grep in a way. It was just like G/RE/P that was meaning like just do a global search for a regular expression and print the results. And so that's kind of the name, where the name grep came from, right? So it was just extracted out of the editor into its own command. Then like in the 80s, so we were talking like 30 years after the initial paper, which I think is kind of nuts how slow this evolved. We have Perl that just took it in and added a bunch of features. 10 years later, PCRE came about. That's like the Perl compatible version. So it's just a C library that re-implements a bunch of the Perl features. And that's what's used in PHP. So if you do a preg match in PHP, you're using the PCRE library. Yeah, by now, like PCRE has a lot of more features than Perl, so it's like Perl is the compatible one, sort of. With it's complicated, but then finally we have the word like grep that became a verb and a noun in the Oxford Dictionary. So like what, 50 years later. So one thing though to mention is in like the concept of regular expressions it's a mathematical concept, so it's fairly limited in some ways, like to express some very strict things. And like regexes, as we have them nowadays in programming languages, can do a lot more. So they go beyond the mathematical concept, and I think for that it's good to call them regexes and not regular expressions, because they're kind of two separate things. So I'm trying to use regex as a term for this. If you want to say regex instead, it's fine, I guess. I don't know what the correct one is, but I'll just say regex. So let's dive in. Concepts first. Just a few rules for the talk. We have patterns. So patterns are just like the regular expressions. They're in yellow. The subject string is what you're matching against, and the match is what comes out of it, like out of the regex engine. So patterns are made of characters and metacharacters, simple. Like just characters are anything that is not a metacharacter. And we'll go through the meta ones, but basically, yeah, those two kind of match the same. They match this U string with a space after. If you want to escape metacharacters, you can escape them with the backslash as usual. Or you can also use the backslash capital Q and backslash capital E to do a like quote, end quote. So everything between those is just escaped. So those two are kind of equivalent. Then to get a bit more interesting, we have character classes. I guess you're all familiar with these as well, but I just go through everything just so we're all on the same page. So those just define like that. Between the brackets there we have a set of characters, and we say, okay, we want to match one of these. So this has to match one of either A, B, C, or D. And then we can extend that with ranges. So with the dash we can say, okay, any character between this and that code point. And it's important to know that it's code points and not just characters, because like if you do a capital A to lowercase z, since these are code points, you just look at the ASCII table, and like between all this, you have a bunch of garbage characters in the middle there that you probably didn't mean to match. So just keep in mind that this is, it's not smart, like it doesn't understand your meaning, it's just computers, right? Code points, that's it. You can negate the class with the caret. So just adding the caret means anything that is not between A to Z and a space. And finally, again, escaping, you just use the backslash, but most things don't have to be escaped. Actually, within the character classes, only a few characters have a special meaning, and those are like the slash, the caret, the closing bracket, and the dash. So you don't need to go about like escaping dots and so on. You can use these, again, like if you think back to code points, with the hexadecimal escape codes like this, you can do anything that's between hex 0 and 1f, which is like the range of non-printable like control characters. So if you want to remove all these from a string, for example, that would be a good way to do that. You can also match Unicode, which can be interesting if you want to match really weird characters. Again, like the range is still the same, it's still code points, and you have this X with the curly braces to go beyond the first 255 characters. You can use the characters in line as well, it's exactly the same, it looks a lot more fun. Then we have, like, since those character classes tend to be a pain to write, like because they get very verbose, there's a bunch of shortcuts for them. So the word one is just any word characters, so any A to Z, capital or lowercase, numbers and underscore. I'm not entirely sure why, but that's just the definition. So you have the word one and you have the opposite. So the backslash capital W is the reverse. So it's any non-word character. You have the same for digits with D and white space with S. And then you have a million others for all the like Unicode style character classes. So if you want to match any Thai character, for example, there is a class for that. So it's like it's going to be backslash P, L, and then some code for Thai. I don't remember, but or just write Thai, I think. And like every alphabet has a class, and all those types of characters, like the weird circles I had in the previous example, they're also part of some class of characters. So you can match specific groups like that. The dot means anything but a new line, and that's quite important. It's like anything but a new line. And you might know that if you add this S modifier at the end, then the dot means really anything, anything. So in that case, what it kind of maps to is this, like this, the second example, there is a backslash S or backslash capital S. That means anything that's a space or not a space. So that means anything, right? I just point this out because, for example, in JavaScript, you don't have the S modifier. So if you want to match really anything, you have to do it yourself using this kind of hack. So it's good to know, like just to have a clue how to do it. Then we have subpatterns. So subpatterns are just like the round braces, the parentheses. In this case, we match bomb or boys using the alternation. So with the pipe, you do an alternation. It's basically a if-else. So it's either that or that will match. one good thing there to note is you can name them. And that's, I think, is very important. If you look at this sort of example where you have a preg match, then you store the matches. Typically, you're going to have the match 0, match 1, match 2, and so on. And like the 1 is the first braces, and 2 is the second braces, and so on. Now, if you have like 8 matching groups, this tend to become quite painful, just because it's like not extremely readable. It's as if you would write like code with your variables being all numbers. It would just be insane. The other issue is if you modify the regex and add something in the beginning, all the offsets are shifted by 1, right? Or like everything that follows is just like +1 in the counter. So that tends to introduce bugs fairly easily when you modify regexes. So for that reason, I would really advise you to name them. So you just do this like $P, and then you have a name in the angle brackets. And using that in your match array, you get like match and then a key with the name you assign. So it's a lot easier. Also, I forgot to mention, but if you have any questions, feel free to interrupt at any time. And if you're in the other room, I'm sorry. So, as I mentioned, like alternations, Bob or Bobby. Problem is, the engine, when it matches something, it's like, okay, I matched Bob, so that's fine. It stops there. So in this case, that's not exactly what you meant. So if you swap them and have the more specific first, whoops, that's not what I meant to do. More specific first, you will match the correct thing, because it will first expand the Bobby, and then it will find Bob if needed. You can also write it with an optional subpattern. And this introduces this concept of like quantifiers for optional things, right? Like the parenthesis there with the B is optional, and this applies to the whole parenthesis. So quantifiers, they're mostly there to kind of deal with the uncertainty, because typically if you use regexes, it's because you can't do like a straight equality on something, right? If you know exactly what the options are, you can just match on that. But if you have some uncertainty, then regexes are quite nice. So there are a few quantifiers that allow you to describe this. The question mark for 0 or 1 time, so that's just it's not there or it's there. The star is the same, but it's like it can be there multiple times. And plus, it has to be there at least once, but it can be there still many times. And then if you need very specific rules, you can use the curly braces to say, okay, it's between like 2 and 3 times, this has to be there. So just some quick examples. In this case, Jamaican or Jamaicans is valid, right? The question mark only applies to the S, because there are no braces, so it only applies to what directly precedes it. In this case, we match ST or ST-O, like any amount of O's is valid. There we want at least 1 O, but more is also okay. And finally, this one is a bit more weird. If we want to match a pair of A's, at least once, but maybe twice, what we get is like, first we get a matching group that has 4 of them in, right? Because we matched 2 pairs, but then we say maximum 2 pairs of A's. So after it matched 2, it just stops, and then it will create a second matching group where it's like, okay, I got 2 more pairs, and then finally we have only 1 pair. So we match 1 pair, and that's fine. Then we can turn these into lazy quantifiers. So by default, as I showed, like they just take as much as they can, right? With this example, we just take like 2 pairs if we can. If we make that lazy with a question mark, so in this case, the question mark doesn't mean like 0 or 1s. That's a bit of a twist there. If you put a question mark on a quantifier, it just turns the quantifier into a lazy quantifier, which means it's going to match as little as it can and just like stop once it satisfies the rules. So in this case, you see it just matches pairs, like single pairs every time, because that's just good enough. What this can be useful for is like for an example of, like people always say don't match HTML with regexes. You can still do it, I guess, but anyway, it just highlights the problem very well, because typically in HTML, if you want to get the contents of one tag, like one EM tag, and you have two, well, it's just by default with dot plus, it's going to match as much as it can until the last /em it finds. And that's not really what you meant to do, I guess. So if you add the question mark on the plus, you make the plus lazy, so it stops as soon as it finds the /em. And there it just fixes the use case. Possessive quantifiers are kind of the opposite of the lazy one. I mean, so by default they're greedy. Then we have lazy to step down one notch, and possessive is like making them sort of ultra greedy, where it says do not give up your matches. So that's quite difficult to explain, but I have an example. So in this case, we have trigger, but like we match trigger where the first G has a plus, right? So what happens, like in the first use case, in the first line there, the first G with the plus will match both, and then it tries to match against the E, and it cannot match that like against the second G, because that just doesn't match. So it will say, okay, I'm just by default I'm greedy, so I consumed both G's, but it's fine, I can drop one. So it just goes back, drops one of the G's, and then the second G can match, then it's fine. In the second case, we have 3, it's the same process. It will consume 3 first and drop to 2, so that the second one in the pattern can be matched. If we turn this into possessive, using just adding a plus to the quantifier, then it doesn't match anything anymore, because after the first one has consumed both G's or the 3 G's in the second line, it can't go back. Like, it cannot give up some of the things it matched. So it's just saying, okay, well, that's it. Like, there's no more G's to consume after, so it's not matching. If this wasn't clear, I have more examples after. So, anchors just let you define like anchor points in the string, right? So it's just saying, okay, this must be the beginning of the string or the end of the string. If you have the M modifier, that just says multi-line, so the anchor points become end and beginning of the line, of each line in your string, instead of being like end of the string. So that would look like this if you match in like any kind of amount of emails in a string that's multi-line. This would look something like that. Don't use this email pattern in production, but it's just a demo. There's one problem though. The dollar is actually, like the definition of it is not really the end of the string, it's the end of the string or just before a new line at the end of the string. So if your string is terminated by a new line, the dollar will still match, which can be okay, but can also mess you up, I think, depending on what you do. Like in this case, if we validate the email, we just say, okay, I want to check, do I have an email in this string? And that's it. Like, is this string just made of an email? Then you say, okay, yes, it matches. Now, do you use the result of the match? Like, if you use what you matched, right, like the green part here, then it's fine because you extracted the email out of it. But if you use the original string because you think, okay, it's a valid email, then you suddenly store something with a new line at the end, which probably isn't what you meant to do and might induce some amount of issues that I can't even conceive of. So just be aware of that and maybe don't use it. You can use the backslash lowercase z, and so the capital A and lowercase z are like the equivalent of this caret and dollar, except they mean really like the absolute beginning of the string and absolute end of the string. And I believe this also applies with the multi-line modifier. So if you need to match multiple lines, then don't use these. But if you really want to make sure you have anchors that are meaningful, that's probably a bit safer. Back references let you do things like here, if we want to match single quotes or double quoted strings. Like if we take the naive approach of saying, okay, I have a quote that's a single quote or double quote, then I have some stuff like word characters, and then I have again a single or double quote. You see the problem that we match the mixed one, like the last quoted string is not actually valid, right? It has a single quote and a double quote. So that's not really what we want to do. We can easily fix that with a back reference. So just adding a subpattern there on the first quote, and then we just reference it with the \1. And so we say, at this point, I want to have what matched in the first one. So it doesn't copy-paste the first pattern, really. It copy-pastes the result of what the first subpattern matched. So in this case, we see, okay, like in the mixed one, it will say, okay, I had a single quote, so it needs a single quote there, and it doesn't match. You can again do this with the named subpatterns and do like a reference to the name and not just the index. So that's a bit more clarity. It's obviously a bit longer, but if you have long regular expressions, I think it's a bit safer that way. Lookaheads let you like look behind and after. Behind and after what you're currently matching. So if we want to match like words that are surrounded with wildcards, again, naive approach, just have a wildcard, word characters, another wildcard. It's fine, like it works, right? But we match the wildcards, which maybe we don't want to, like if we're doing, I don't know, like a markdown parser or something, we want to just extract the word. We don't want to have to clean up the wildcards. So in this case, we can just use those look ahead and look behinds. And doing this, we just say, I want to have like word characters, but there I want to check that before it is a wildcard and after it is a wildcard. So this syntax there is the like, I'm not gonna read that out loud because it's crazy, but you're just asserting that there is something equal to that before and after, but this is just an assertion. It's not capturing, like it's not matching anything, so you don't find it in the match, but it is still like asserted that this is a fact. Now if you want to do the reverse, like match anything that's not surrounded by wildcards, we just say, okay, like I'm gonna use the not, like assert that there is no wildcard before and assert that there is no wildcard after. It's fine-ish. You might spot the problem there that we're starting to match like the middle of the words because obviously, yeah, like if you, before the E there's no wildcard, so it's fine. And after the second E, there's also no wildcard, so this looks like a word without wildcards around it. So how do we solve this? There is one more like shortcut that we can use there, the \b. The \b expands to this whole gigantic thing that looks quite complex, but really all it says is that you either have a non-word character followed by a word character, or you have a word character followed by a non-word character. So I don't know if that made sense, but it basically just means you're at the word boundary. Like you have something that's a letter or an underscore on one side and not on the other side, or the other way around. So if you just apply that, just add them. Again, since these are just assertions, they don't match anything, then we solve the problem. Because if it tries to match the EE there, before there's a K, or after there's a P, those are like word characters. We're not at the boundary, so it does not match. Again, if there are any questions, feel free. Conditionals, just one word, don't use them. Like, it's probably not a good idea. Like, unless you really know what you're doing and you really need them in one pattern, you're usually better off just doing the match and then doing your logic in PHP or whatever language you're using. Just saying, okay, I matched that or I didn't match that, so I'm going to do another query, like another preg match and so on. Because they tend to create like fairly convoluted stuff. So yeah, just don't want to delve into that too long. We have delimiters, which are traditionally slashes, because well, in like Perl and JavaScript and so on, it's kind of the only delimiter that's allowed, so people tend to default to that. But it really kind of makes me mad because well, we're working with the web and we match a lot of URLs. Like, it's a fairly common use case to do a preg match on some URL thing. And then you end up having to escape all the slashes, not because they're a meta-character, but because you made it your delimiter. And then suddenly, like, your pattern looks quite horrible. If you just use something else, like curly braces, you don't have that problem. So I would say, like, if you're in PHP, you can do that. If you're in JavaScript, you can't, but yeah, that's just life. PCRE is pretty nice. I wish it was used everywhere. But another like little tip, just in case you want to use double quotes, I would say don't, because again, like in PHP, if you have a single quoted pattern like this, and you want to match like literally just a backslash and a dollar, you actually need 4 backslashes already there, because each pair of backslashes will resolve after the string resolution to 1 backslash. Then you're left with 1 pair of backslash that you can then like escape for the regex engine to match a backslash. Like, it's just, you know, it's too many backslashes. So if you add like double quotes to that and have even more stuff to escape, you're gonna go nuts. Modifiers, I mentioned a couple of them already, but just to quickly go over, you have the I to make it case insensitive, multi-line I mentioned, single line as well. The U is used if you need to address any Unicode, like character class or even the character escapes. Like, if you need to do that, then you need to add the Unicode flag. The D makes the dollar the equivalent of the backslash Z thing. So it just makes the dollar actually match the end of the string and not this end or maybe a new line. So that's another way to do it if you really want to like keep using the dollar sign to mark the end of the string. And then finally we have the X, which allows you to add white space and like more comments. And I would say that's probably a good idea. Because like if you have something like this, for example, that's not extremely self-descriptive, like this backslash X1F4A9, I don't know who knows all the Unicode escapes, but you probably don't. So if you use the X modifier, you can just expand that and have a bunch of comments. And so you have, you say, okay, there's like a pile of foo character. And so that's a lot more clear. Now, one thing to take care of is, like you see here, we had a space in between, right? We have the googly eye thing, and then a space, and then the pile of foo. So, as you say, with the X modifier, you say, okay, spaces actually don't matter, like they're not relevant. If you want to match explicitly a space, here you need to escape it. So you need to say, okay, that's an actual space, not just like some white space in my pattern. This, I would argue, is very important as well, like, just if you want to improve readability. So just as an example, we have an extremely long pattern that's in Composer is made to match the license. Don't ask. So the package license is just like this standard for that, and so this long pattern and page 2 of the long pattern is it's just doing that. And you see it's a bunch of conditionals and like back references to things and so on, so it's getting really complex. But it's also, down the line, it's a lot of comments. Like there's quite a lot of content in there, it's just comments. And without that, if you compact it all to one long thing without white space or comments, like forget it. There's no way ever anyone will touch this. Okay, so that was that for the features, let's say. Now let's look at the engine and like how they actually work. I mentioned this shortly already, but like the first match wins. So if once it found a match, it just stops there. So you need to keep that in mind. But that you will usually notice it anyway, pretty quickly. The other point is that the engine prefers to match like the whole pattern than not to match the whole pattern. So if it had something, like in this case, if we look at what really happens in the engine, now in the second row, I'm very sorry, it's gonna get maybe hard to follow if you don't see the laser. You have on the left, I'm gonna try to use words and no laser. On the left, you have the pattern that's like, so you have two heads in the engine. You have one head that follows the pattern, and you have one head that follows the string. And on the left, you have the pattern, on the right, the subject string. So it just goes in and it matches this set or set foo. It matches set, so it's happy, it jumps at the end of that on line 7. It jumps to bar, and it tries to match bar, but that doesn't happen. So it's, okay, I can't match the overall string, so I gotta go back and try something else. So you see this red backtrack there, that just means the head on at the pattern level, like the left-hand side, the head just went back into the pattern to try something else. Or like it just backtracks to some position. So in this case, we try the other branch of set or set foo, and it matches again, it matches set foo, and at the end, line 15, it tries again to match bar, and in this case, it works, so we matched successfully. But you see that, like, since it couldn't match with the first one, like even though we have this first pattern here where we use set or set foo, which is not really the right way to do it, it still found a way to match because it had to. So as I explained, yeah, we have this backtracking. Now, if we take this again, this email pattern, and we try two subject string, like one that's a valid email, like foo@bar.co.uk. The other one is bar.co.uk.foo, and then there's a dot at the end, and that's the key point. Is that the dot at the end is really invalid. The foo in itself is not really a big issue. It could be a valid subdomain these days. You just like, I don't even know what are valid subdomains, like top-level domains anymore. So the pattern looks like this, right? You have not an @ sign, and then like one or more times, then you have an @ sign, and then you have like the first part of the domain, followed by a dot, and then another domain part. And this whole block at the end can be multiple times as well, because like in the UK with the .co.uk, you need to match more than one, right? Or if you have subdomains, you also need to. So if we look at some like the successful match, we have again, like it goes through and it matches everything, like until the domain, it's pretty straightforward. And then we have line 10, we have the first backtrack, because it sees, okay, like after it matched the bar, the .co rather, so it matches .co, then it jumps at the end and it's like, okay, I have a plus there, so I need to keep trying. So it just keeps trying, and it matches .uk as well. And then it keeps trying, but there's nothing left, so it just says, okay, like I I'm done here. At line 13, it backtracks, but there's no dot to match, so it just finishes with that. Jumps out, and checks that there's like the dollar is matching. So are we at the end of the string? Yes, good, successful match. Now we look at the other one. So the invalid email. There you see what's called like a typically catastrophic backtracking pattern, where like again it's pretty much the same until this line 16, where we just matched everything, and then still it's in the plus there where it tries to match. So it matches the dot, and that's fine. But then it tries to match line 17. It tries to match the some more domain words, and there's just nothing. So it says, okay, well, that didn't work, so I'm just gonna backtrack. And there it does two things while backtracking. It backtracks like on the left side, but it also drops some characters on the right. So it says, okay, like if I drop the dot, and so it kind of drops the whole match here, then it jumps out and says, maybe that's gonna work. So we have to try. Look, are we at the end of the string now? Nope. Okay, that didn't work. All right, so let's go backtrack again. We were here, so just drop the last O and try again. Are we not at the end of the string? Nope. Damn. Okay, let's drop another O, and again and again and again. So you see that it just like drops everything, like character by character. And this can lead to situations where you have like these errors saying you exceeded the backtracking limit, which is usually like 1 or 2 millions. So it seems fairly high, but you see that with just a silly query like that, like a silly pattern, if I submit an email that's 2 megabytes of string, then it's gonna drop them one by one, and then those 2 million, they come quickly. So how do we fix that? We just make it possessive. So you might remember these possessive quantifiers. So we just add a plus. So if you look just on the left-hand side, I just added a plus inside the domain bit there, where we just say like, the word characters that you match, you cannot give them up. So in this case, we still have some backtracking, but only so much as we have dots. Because every group of letters will just be dropped at once. Because it can't like give one up and then try again, give one up, try again. It just says, okay, like this whole block, it didn't match, so just give it up at once, and then you see at the end it goes back really quickly. Just like in 3 lines, every time it checks, okay, are we at the end? Nope. Okay, drop the whole thing. Are we at the end? Nope. Again. So we reach the same conclusion, right? That this is not a valid email, but we do it much faster. So it went like from 32 steps to 20, but if I post a megabyte of email address, you go from like 1 million steps to still 20, or like. The difference can be quite big. So I hope this clarifies really the possessive quantifiers and what they're good for. Like generally, you want to use them, but it's a bit hard sometimes to know where to use them. So like I tend not to do it by default, but it's really good help to remember, because sometimes you have some performance issues, and then using that can really save you. Just a quick note about the JIT. So in PHP 7, we have they enabled like PCRE JIT. So you have the just-in-time compilation there for the patterns, and that makes it quite a lot faster. So the faster I got there, like on this test, so the JIT would be like the 1x, and so without the JIT, I got just like twice as slow. So that's quite good if you double the performance there. The problem I had though is, like you see on the top pattern that didn't use the possessive quantifiers, on really big files, it would just like crash with the JIT. So that's not really ideal. But then again, like there was a performance issue anyway, right? So like we were like 6 times slower, and then with the JIT it would crash, which kind of highlighted the issue. And then once we fixed the pattern, we just got it really fast, and then with the JIT it's even faster. So use it or don't, I'm not sure, but it's there. I think it's disabled by default. So just a few sample use cases of like things you can use regexes for in like day-to-day basis, I would say. Like one thing I do a lot is search for code, not using an IDE because I don't use an IDE, so it's like I understand that a lot of this is easier with an IDE, but I end up searching a lot with regexes. And like in some cases, I think, you know, stuff like this, you can't do it. Like PHP Storm is really good, but it's not that good. You can't ask it for any function call to this function with this argument, I think. Unless, like, I should stop saying that because one day Gary is gonna come up like, no, we fixed it. I think you still can't. So anyway, like this is a simple way, right? And what I want to highlight here is that like this pattern is completely wrong. Like it's obviously this doesn't match only if test. So you have like foobar and then just we want to have a bracket here to know that we're in a function call. And then we have random anything and then test. Right? And I use the \b there because let's say I want the string test. I don't want to do the whole pattern with the, you know, the single quote or double quote and so on. I just want the string test somehow delimited. It doesn't matter much. So this won't match it only if it's the third, but it matches and is probably good enough. And that's, I think, is very important, is to see like what the domain is and, you know, what can you get away with in a way. Like depending on the exact situation, you might need to be more or less strict. So if you get like 200 results with that, maybe just add some more specificity. But by default, it's probably gonna work. Right? Like if you find 10 results in your code base, you can probably go through them quicker than you will tweak your regex. Like similarly, like just another, again, like these are not perfect examples, but I think they highlight something. If we want to have, let's say we have a class foo, and so we usually store it in a $foo, right? But if you're not consistent, this is not gonna work. Like if you search for something that's called foo and then we call set something on it, it depends a bit how you code. Like if you're more consistent, it will pay back at that point, but might not apply to all code bases. Stripping stuff is really easy with like preg-replace. If you say you want to remove a prefix, like you could do this, you know, using if like strupers, like if there's a, you know, if, or even a substring, like saying, okay, if the first characters of that string are those 4 first characters, then I'm gonna do a substring and remove them. Sure, but then you have like a if block and so on, and I think that's a lot easier like that. Just have one line and it's pretty clear and readable. Like I think anyone can pretty quickly understand it. Similarly for like trailing white space, for example, very simple. This one maybe not very simple, but I don't want to go through it like in extreme details, but it's just it's what we use in Composer for finding classes, like when you use the class map autoload stuff. This just has to find a class, like any class in any file. Doesn't matter how it's called or in which path it is. It just like scans all the files and finds classes. So this has to be like really correct and flexible. And at first we used like token get all because that's the obvious way to do this correctly. You do token get all. So you get the PHP tokenizer that reads the file, returns you an array with like all the tokens in that file, so you can loop through them, and when you find a class token, you know you got a class name following, so you just go to the next token, get the class name, easy and correct. Problem is, there's someone out there with a file that has like 2 megabytes of PHP in it. I don't know why, but that's just life. There is a lot of stuff out there that you wouldn't expect. And token get all in these cases will just blow up because like memory usage goes through the roof because it passes the whole file and like creates a token for every little thing. And so you just explode the memory usage. So we had to pretty early on replace that by some other solution. And so what we ended up doing there is like doing something that by default you might think is completely nuts and impossible, because if you think about it, matching class followed by some name in a PHP file, like a lot of stuff can go wrong. Typically you're gonna have an @ class or something, annotation in the comments, or someone just having a sentence where there's the word class in it in some comment somewhere, or like a string that has class, whatever. You know, like a lot of stuff can go wrong. So what we just have to do there is like remove the uncertainty and like clean up the domain to a level that we can actually apply regexes to it. And so if you look at the main steps, it's like removing all the here docs and the now docs. So those are easy to match with regexes, just remove them. We remove all the strings after that because those are also easy. And again, like there, you know, if we mess up and remove a string in a comment, it doesn't matter, right? So it's all about like having the right order and kind of knowing the domain. Then we remove like non-PHP code. And at the end, we're left with something that's like kind of just PHP enough that we can match class followed by some class name, and it, as far as I know, never fails. Yeah. Just also really short example, if you want to split tags, let's say, if you have like a user submitted tag list that can be either split by spaces or commas because people are just inconsistent, well, that's a good way to do it. You split by anything that's a space or a comma. And you can have even like 3 commas and it will just group them into one, so you don't get weird issues like with explode where you would get like empty array entries. And just a real quick note about grep. If you use grep, use rather egrep or the grep with the -E. Because without that, like by default, grep uses the POSIX regular expressions, and I don't know why exactly, but they thought it was a good idea in the standard to make all the metacharacters non-meta characters by default. So if you have like braces and a question mark to make something optional, you're gonna have to escape the braces and the question mark to make them into meta characters, which is completely backwards from everywhere else you use regexes. So it's like, I don't get this, but that's just how it is. So definitely use that or just have an alias or something. So a quick question, considering all you maybe learned. Who would say that this matches? Or I'm gonna give you 2 seconds. Oh, okay. Who would say that it doesn't match? Okay, a few timid hands. Who would say that it does match? Did you just raise your hand at both? No? Okay, I'm not sure. I lost track. Okay, so we have very few timid hands and many people that don't even dare. So it does not match. And like the reason is, again, that this is just like this question mark equal U. It's just asserting, it's a look-ahead assertion that there is a U following, but it does not match, it does not capture the U. So if you think back to the 2 engine heads, like it looks on the right side, it looks that the string has something, and then if that matches, it moves the left-hand engine head. Like the pattern head moves, but the match head does not move. It doesn't capture anything. So this, like, just if you just match that, then it will match the Q because it's followed by a U, but it does not capture the U. So afterwards, like on the top pattern, it would try to match an I, and it just can't. Now, who got this and is very sure about the answer? Okay. So, how do we remain sane while using regexes? Just be aware of limitations, definitely. Like, again, like if we think back to this policy of like never use regexes for matching HTML, it's like I don't really agree. I mean, yes, it's probably a bad idea if you want to match any HTML document, because yes, the HTML standards has like enough stuff to shoot yourself in the foot, that's for sure. Like, you can't do it safely for any document. But if you know the domain and you know that, you know, you have clean HTML that you ran through HTML purifier or whatever, and like you know that you only want to look for this exact pattern and that, then it's fine, you know? If you think, okay, this is applicable in this case, it's good, and it will save me a lot of time, then by all means do it. But you just have to think and like know the domain, know the limitations as well of regular expressions. In general, if you match stuff, I think you should keep it like fairly restrictive to begin with, because if you go like dot all, you know, just dot plus everything all the time, you're gonna have surprises, and they probably won't be good surprises. So I think if you start like fairly restrictive, then you're gonna have like false negatives where you see, okay, like this didn't match, but it should have. Then, sure, like just extend the regex to make sure that that it matches. And when you do that, like another thing to really consider is testing. Like if you, let's say if you would like to do TDD and you never got to, I think like building a complex regex is the perfect example for TDD, because it's extremely simple to have a list of things that should match, a list of things that shouldn't match. You put those in tests with like the data provider in PHP unit, and then you run through your regex, and you see, okay, is it passing or not? So you can easily build the test cases first and then work on the regex to make it pass more and more of those tests. And you really want to do that because once you have to modify your regex in 2 months, like you probably won't remember all the edge cases you had to think of back then. So if you don't have a comprehensive test case, this might also get quite nasty. Boundaries are good to keep in mind as well. Like if you do matching, so to match that something is present into something else, the \b is good because it says, okay, it is somewhere in, and there is this word boundary. Like it's usually useful. If you do validation, though, you really want to use the anchors to make sure that you validate the whole string and not just validate that you have a valid email in this long blob of thing. Finally, document. Like really, remember to use those named subpatterns and use the X modifier to expand and be able to have comments and more like clarity with the white space. So that's that for me. I hope that you're a bit less scared now. Yeah, thank you. Just if we have questions, we have 5 minutes. I just have like 3 resources real quick, but think of questions. So regularexpressions.info is the Bible of regexes. Like it has all the info, and it has also all the info about all the engines and all the languages and so on. So if you have to use JavaScript, for example, it will tell you, okay, this is not available, or so this is quite interesting. Regex is the one I used for the flowchart style thing. So it expands patterns, but it only supports JavaScript, so not extremely flexible. And the last one, Regex 101, has the debugger view that you saw, where you see the engine head and the pattern and the match. And so this one is really useful, and this one supports full PCRE, so PHP style regexes. Thank you. Any questions? Also, if you have feedback, or if you want the slides,
once again about HTML tags or maybe any tags. I think on the slide you've shown a few open close tags in parallel. What about the nested tags? Does lazy helps with nested?
No. Like if you have, for sure, if you need to match like nested HTML stuff, you're gonna be in a world of pain with regex. Like it's, it might be again possible in some limited cases, but I don't think it's worth it. Like there are definitely better tools for that. So don't, like you're gonna waste your time, So, yeah, it really depends on what you're trying to do. Anything else? We're coming to the other room. They're all gone. Damn. Okay? Nothing? Thank you.